One star in the sky lost 22% of its light in a matter of days. Nothing we know of should be able to do that. Astronomers found it by accident, and years later they still cannot agree on what is blocking it. The star sits about 1,400 light-years away in the constellation Cygnus. It is bigger and hotter than our Sun. For most of its life, it behaved like any ordinary star, glowing at a steady, predictable brightness. A telescope called Kepler watched thousands of stars at once, hunting for tiny dips in their light. When a planet crosses in front of a star, the light drops a little, then returns. That dip is usually a fraction of a percent. This star did not follow the rules. Instead of a neat, tiny dip, its light plunged. One event dropped it by 15%, another by 22%. Then the brightness came roaring back, only to fall again at random. So what could block nearly a quarter of a star's light? A planet the size of Jupiter would only dim it by about 1%. Whatever passed in front of this star was enormous, and it had no schedule. Volunteers scanning the data flagged it as strange. Even the computers could not classify what they were seeing. The first guess was simple. Maybe a swarm of comets had broken apart and drifted across the star. A cloud of icy fragments could scatter light and cause uneven dips. Then came the twist that unsettled everyone. Someone dug up old photographic plates, images of this same star going back over 100 years. Comparing them, one study found the star had been slowly, steadily fading for a century. Not just short dips, but a long, quiet decline. Comets do not do that. A passing comet swarm is a brief event, not a 100-year dimming. Something about this star was changing over lifetimes. The astronomer who led the research became so well known that people started calling it by her name. It is often called Tabby's star. Here is where the numbers get sharper. When dust blocks starlight, it blocks blue light more than red. Small particles scatter certain colors. So scientists measured the color of the dimming, expecting a clue. And the light did change color. The dips blocked more blue than red. That pointed to fine dust, not a solid object. But a solid object, like a planet or a giant structure, would block every color equally. A perfectly even dip would mean something opaque. This was not even. This favored dust. So the mystery narrowed, but it did not vanish. Because dust that fine should be blown away or should glow with heat we could detect. And the century-long fading still had no clean answer. Here is the part that made headlines around the world. One scientist suggested that if the dips were solid and evenly shaped, they could point to something built. A vast structure surrounding the star, catching its energy. Astronomers call the idea a Dyson swarm, a hypothetical construction by an advanced civilization. That idea traveled fast. Telescopes listened for radio signals coming from the star. They pointed instruments at it, searching for any pattern that machines might make. They found nothing. No signals. No heat signature from a giant machine. Silence. The color change had already argued against a solid structure anyway. If light passed through and turned redder, it was passing through dust, not around metal. This is the part most people get wrong. They remember the wild headline and stop there. They think the star was solved or that scientists seriously believed in a built structure. Neither is true. The construction idea was always a long shot, floated to test what the data could rule out. And it was ruled out. The real story is quieter and stranger. The best explanation now is dust, uneven clouds of it orbiting the star. But no one fully agrees where that dust comes from, or why the pattern is so chaotic, or what drove the slow, century-long fade. Some think a planet was torn apart, leaving debris that still drifts across our view. Others think the star has rings of dust tilted at odd angles. Others argue the old photographs were simply inconsistent, and the century-long dimming was a measurement error. They're still arguing. So what did this teach us? It showed that citizen volunteers, ordinary people combing through data, can find things machines miss. This star was flagged by human eyes noticing what did not fit. It also changed how astronomers hunt for the unusual. Whole projects now watch for stars that behave in ways nobody expected, instead of only searching for what we predict. The oddities, not the patterns, became worth chasing. And the star keeps doing it. Even now, telescopes catch it dipping, brightening, dipping again, refusing to settle into any clean rhythm. So picture it. A star bigger than our sun, 1,400 light years away. Its light drops by a fifth, comes back, and no one can say for certain why. Not comets. Not machines. Probably dust, but dust that behaves like nothing else we have measured. What is out there, orbiting quietly, blocking a fifth of the sun's fire and hiding its own shape?